Okay, so how is everyone today?
Great.
Great. Friday. Very good.
Yay.
All right, so then last time we were talking about equations. We still have some things to say about equations. All right. So let's start out with an example like this. So how about the absolute value of 4x minus 5 is equal to 11. Okay, so how do we go about solving this one? Well, so notice that the equation kind of has a structure like the following. Suppose I cover that up, whatever is in that absolute value. So what could I put into that absolute value so that 11 would come out? 11. Is that the only thing? A negative 11 would work too, right? If we could arrange matters so that whatever it is I'm covering up is 11, that would be a solution. And if we could arrange matters so that whatever it is I'm covering up is negative 11, then that also would be a solution, right? So there's two ways to achieve this. So viewing it in that way and uncovering that, what is being said is that, well, if 4x minus 5 is 11, that would work. And if 4x minus 5 were negative 11, that also would work. Both of those would work. So here's the idea, is that the equation sort of looks like this. Absolute value of, something is 11, and then what to put in there? What can we put in there? Okay, 11, negative 11, or 11 to make it work. So then doing that, so I'm just copying it down. So what that means is that there's two possibilities. So this equation splits into two pieces. One possibility is that 4x minus 5 could be negative 11. Another possibility is that 4x minus 5 could be 11. All right, so then now both of those equations are simpler in the sense that neither one of them has absolute value, and we can just solve them in the usual way. So doing that, for the one on the left, we'd have 4x is equal to negative 6. And for the one on the right, 4x is 16. And then dividing by 4, we'd have x is what if we divide by 4? Negative 3 over 2, because it cancels a little bit. And then dividing this one by 4, we have x is what? 4. All right. That's interesting. So, since this is the first one of this kind that we've done, let's do some double checking. So how about that equation? What is its natural domain? All reals, right? Because consider the thing that's going inside of the absolute value, 4x minus 5. What's 4x minus 5's natural domain? All reals, right? There's nothing that can go wrong with that. And then what kind of stuff can you plug into the absolute value? All reals, right? So nothing's going to go wrong there. And then what about 11? For what values of x is 11 defined? All of them, right? Right? What is 11 equal to when x is 4? 11, right? What is 11 equal to when it's raining outside? 11, right? So then, so can you see that there's nothing that can go wrong? So the natural domain is all reals. Furthermore, concerning these algebraic operations, did we do anything that was questionable? Like, did we ever multiply or divide both sides of an equation by 0? Yeah?
So when you split it, you don't have to carry over the absolute value anymore?
No.
Okay.
Because the idea is that, again, so looking at this equation, it has this structure. Absolute value of whatever I'm covering up is 11. Now, there's only two ways to achieve that. So this thing I'm covering must either be 11, that's possible, or negative 11. If what I'm covering up is an 8, then the equation is false, right? If what I'm covering up is a negative 18, the equation is false. So the absolute value disappears in that split. Other questions? And so, you know, all these operations, we didn't multiply or divide both sides by 0, so that's all, so nothing went wrong there. Did we square both sides at all? No, we didn't do that. So all of these operations are completely legitimate, so that's really the answer. So, but nevertheless, out of an abundance of caution, maybe we check. So how about we check? I'll check x is negative 3/2. So plugging that in, so absolute value of 4 multiply negative 3/2. Subtract 5 equal 11. All right, so then 4 multiplied by negative 3/2. So that'd be, well, if I divide by 2, that'd cancel a 2, so it'd be 2 multiplied by negative 3, which is negative 6. So negative 6 minus 5 like that, absolute value equal 11. And then, you know, that's negative 11. So is that true? Yeah, that's true. And how about we check the other one? X is 4. So absolute value of 4 multiply 4 subtract 5 equal 11. So that would be, you know, 16 minus 5 in absolute value equal 11. So absolute value of 11 equal 11. Is that true? It's true. Good. So it really does work. By the way, I just want to remind you that if what you wrote down on your page looks like this, then you need to stop doing that. Okay? Or if this one looks like this, you've got to stop. Okay? That's not acceptable penmanship in a math class. Good. Any questions about it? All right. So here's another one. So I want you to think about it, but only have your thoughts on the page. Please don't say anything out loud. So please solve. Absolute value of I don't know, 3w minus 10 is negative 4. Right. So, you know, it kind of looks similar to the previous exercise, a little bit. But you know, so whatever you've written, if you were going to make the mistake that I'm trying to let you know exists, if you were going to make the mistake, you would have made it by now. So if you did something like this, or started to do something like this, you've made a serious error. Because, you know, just like we said for this one, the idea was, well, what if we just cover that up what would I need to put in there so that an 11 would come out? Well, 11 or negative 11, right? And then now the question is for this one, covering that up, what would I need to put in there so that negative 4 would come out? What could you give as input to the absolute value so that negative 4 would come out? There isn't anything, right? The stuff that comes out of the absolute value is going to be 0 or positive. You can't get negative stuff to come out. It doesn't do that. So the correct answer is that there's no solution. No solution because the output of absolute value is never negative. All right. So nevertheless, I want to write something down. What this is this is the most common incorrect answer. The most common incorrect answer to this is for students to treat it just like the previous one, to say like this, to say, well, either 3w minus 10 is equal to negative 4, or 3w minus 10 is 4. So, if you're writing that down, be sure to note that that's wrong. So that's the most common incorrect answer. So it's incorrect because, after all, there's nothing that I could be covering up so that negative 4 would come out. Any question about this one? All right. Another one? How about absolute value of 5 minus 4z divided by 8 equals 0. Please solve. All right, so how about this one? Will this one, will it be like the first one? Will it have solutions, or will it be like the last one, no solutions? It'll have one solution, right? Because in the end, now the question is that, again, sort of treating this structurally the same way as the previous ones, whatever I'm covering up there, what would be necessary for me to reveal so that the equation would be true? It would have to be 0. It couldn't be a positive thing, because if it were a positive thing, then the absolute value of that would be positive, so it couldn't be 0. And what I'm covering up couldn't be negative, because if it were negative, then the absolute value of it would be positive, and it wouldn't be 0. Right? So the only possibility is that I must be covering up a 0 in order for the equation to be true. So it must be the case that 5 minus 4z all over 8 is equal to 0. Okay, so how do we go about solving that equation? Well, you multiply both sides by 8. Because if you multiply the left side by 8, that gets rid of the denominator. And 0 multiplied by 8 is just 0, so that's nice. 5 minus 4z. So 5 is 4z. And divide by 4, so 5/4 is z. Okay, any question about this one? All right. So now we've been talking about absolute value a little bit, and now I want to make sure that you understand You have a way to think about absolute value visually, so let's plot it. So we're going to plot y is absolute value of x. So if x is 0, then what's y? 0. And what's the absolute value of 1? 1. So 1, 1 is on there. Absolute value of 2? 2, right, etc. And these just keep going up like that. Okay. What's the absolute value of negative 1? 1. Right, so that means that negative 1, x is negative 1, y is 1 is also a point. So that one right there. What's the absolute value of negative 2? 2. So it just keeps going up this way. So then if we connect the dots, then it looks like this. And so from now on, when you're considering an exercise that has absolute value in it, I want you to keep in mind that somehow, somewhere, there's a v, probably, lurking around in the problem, if you could sort of look at it visually. Now, I want to make 3 little plots here to remind you of something you already know. So specifically, I'm going to plot, so this one up here, this is y is absolute x. And then for this one, I want to plot something y is equal to some negative number, so like y is equal to, say, negative 2. So what will that look like when you plot it? Horizontal line. And where will it be? Right. So at negative 2, and what I want you to observe is that in particular that more or less just means, for our purposes, below the origin. So, y equal negative 3 is also going to be below the origin. Y equal negative 33 is going to be below the origin. All right. What will y equal to, say, 4 look like? Right, it'll be a horizontal line that is above the origin. And then what does y equal to 0 look like? Right, it's exactly the x-axis. Okay, fine. Now, the question that I want us to consider is that what if we have a plot that has absolute value and also one of those lines. I gotta change out the ink here. So putting those together, I could say, well, let's plot absolute value of x and y equal negative 2. Let's plot absolute value of x and y is 0. And let's plot absolute value of x and y is 4. So because we're plotting absolute value of x, all of these have a v. All right. And then now I'm going to plot just those. right? So you can see them. Now, here's the question I want to ask about those pictures. So we've got a red plot and a green plot. How many, for this one right here, how many times do the red and green touch? None, right? So the number of intersections for this one is 0, right? They intersect 0 times. How about for this one? So this one on the right, yeah, this one on the right. Notice that they intersect twice. So there's 2 of them here. How about for that one right there? Just 1, right? So if this is y is absolute x, and if this right here really is y is 4, then notice that they're intersecting, twice. Once here, and once there. And now I want to ask the question. So there's an x value where an intersection occurs, and there's an x value where an intersection occurs. What x values are those? What is that one right there? What x value is that? 4. It's got to be 4. Because if that's y is absolute value of x, and that's y is 4, then the place where that occurs, that must be x is 4. What's that one? -4. All right. So now, the connection that all of this has to the previous page that I'd like for you to observe is that what if I wrote down this equation, absolute value of x is 4? Then what x's will make that equation true? 4 or -4. So if we could view it in that way, the same way that we viewed it on the previous page, but what I'm going to do is also note that, well, what if I just take that and I plot y is equal to the right-hand side, or the left-hand side, I mean. What if I plot that? So I take the left-hand side and plot that, and then I take the right-hand side and plot that. And what I want to know, since those are supposed to be equal to each other, I'm saying that one and this one. And then the question becomes, it becomes this picture, and it becomes the question of what are the solutions to this equation is now the question, where do these intersect? Do they intersect, and where do they intersect? How many solutions does this equation have? 2, right? 4 and -4. How many times do these intersect?
2.
Twice. And the x values are 4 and -4. Okay, so then this one is the same story, except now its absolute value of x is 0. How many intersections? 1. How many solutions? 1. This one is, something like absolute value of x is -2. How many solutions to that equation? None. How many intersections of red and green? None. Right? So can you see it? These are in direct correspondence to each other. So when I asked this question, if you did this, if you made that most common error that I wrote down, that would be like you drawing this picture, this one right here, and saying I see 2 intersections. So can you see what's that issue there? Good. So any questions about this idea? All right. So now we're going to consider inequalities. So inequalities are even more exciting than equations. So in particular, I could say let A and B and C be in the reals, then in the first place, we can have an inequality, like A less than B. And understand that that doesn't mean I'm saying I'm not making the statement that A is less than B. I'm just writing down an inequality. It might be false or true. But it is always permitted for you to add C to both sides, just like equations. You can always add or subtract the same number from both sides. Whoops. So, for example, I could write, well, how about 13 less than 14? False or true? It's true. So if I add, I don't know, 5 to both sides, the new left-hand side is 18, the new right-hand side is 19. Is it still true? It is. So it was, true to begin with, true in the end. And similarly, I don't know, 20 less than 18, false or true? False. So if I add 4 to both sides, now it reads 24 less than 22, false or true? False. So concerning inequalities, it's always fine, just like equations, to add or subtract the same number from both sides. Now, how about multiply? What's the situation with equations for multiply? Is it always okay to multiply both sides by the same number? As long as it's not 0, right? So in particular, for equations, it's fine to multiply both sides by 3. It's fine to divide both sides by 3. It's fine to multiply both sides by -5. It's fine to divide both sides by -5. All these things are fine. You just can't do that with 0. But then what's the story with inequalities? So, can we multiply both sides by a number? Yes, as long as it's not 0. That's still not going to be allowed for the same reasons it's not allowed for equations. But in fact, there's 2 possibilities now. So what it is that if you multiply both sides by C, then the new left-hand side will, it'll be AC. The new right-hand side will be BC. But then what you're supposed to write here depends on the value of C. So in particular, it will be this when C is positive. Okay, but so if we have A less than B and we multiply both sides by C, so that the new left-hand side is AC, the new right-hand side is BC. If C is negative, then what do we have to do? We have to flip the direction of the inequality. So inequalities have more structure to them, more intrigue than equations. So to give an example, how about 20 less than 18? 20 less than 18. Now, if we multiply both sides by, so in the first place, that's false, right? So if we multiply both sides by, say, -2, then the new left-hand side would be -40, and the new right-hand side would be -36. Now, if we don't reverse the direction of the inequality, if we keep it like this, now have a look. So, how about this? Is that true? It is true, right? So it started false, and then we multiplied both sides by -2, and then it became true. So that's not good. That's not good when you have an equation or an inequality and its evaluation changes. Okay, so it went from false to true. So that means that if we to make it right, if we had say, I don't know, 20 less than 40, so that's true, right? And if we multiply both sides by -3, and if we want the truth to be preserved, right, then this will be -60. This will be and this will be -120, and then the direction of the inequality must reverse. So is that true? It is, right? Good. So any questions about it? Inequalities? All right. So this issue of multiplying both sides by a number that's negative flips the direction of the inequality. That's something that we're going to have to pay very close attention to. And we're going to do a great deal, we're going to expend a great deal of effort to avoid losing track of that. So here's an example. How about the absolute value of 4x minus 5 is less than or equal to 11. So now if you look back a few pages ago to the first page, I asked a question just like this, in fact. Except what's the one difference? Yeah, it says less or equal. Formerly it said equal, now it says less or equal. So, but again, the way to consider the question is in the same kind of way. What could I reveal so that the inequality would be true? What's the biggest thing I could possibly reveal? 11, right? 11.1 would be too much. What else could work? How about an 8? Would an 8 work? Yeah. How about a -7? Yeah. What's the smallest thing I could possibly reveal? Which one? So the biggest thing I could reveal is an 11. What's the smallest thing? -11, right? Right? Right. Not. So could I be? What if I'm covering up a -6? Would that be true? Yeah. If I'm covering up a -9? Yeah. What about a -13? No, because if I'm covering up a -13, the absolute values will flip it to 13, and then the inequality won't be true. So what I want you to observe is that in order for this to be true, whatever I'm covering up, it has to be between the 11s. It has to be, on the one hand, greater than or equal to -11, and on the other hand, also less or equal to 11. So that means that the inequality reads like this. So this less or equal this. Whoops. Less or equal that. So that must be true. So this has to be between the 11s. Now, if we wanted to solve an inequality, and if it was just that one, then what would we do? Yeah, we'd add 5 to both sides. And if we wanted to solve an inequality, and it was just that one, what would we do? We'd add 5 to both sides. Right? So, well, that's what we're going to do, except there's not sides now. Now there's just positions. So in general, for an inequality, there can be as many positions as you want. But what we want to do is add 5 to all positions. So I'll add 5 there, add 5 there, add 5 there. So -11 plus 5 is -6, less or equal 4x, less or equal 16. All right. And again, if it was just that inequality, what would we want to do? right? And if it was just that one, what would we want to do? Divide by 4. So in all cases, that's what we want to do. The new left-hand side is negative 3/2. The middle is now x, and the right-hand side is 4. So then we could write that answer in interval notation like this: 3/2 to 4. So, covering that up, and I was asking, what's the biggest thing I could reveal? The biggest thing I could reveal is 11. If I revealed anything more than 11, then the equation of the inequality wouldn't be true. And then translating that into what x's are, this is saying that, well, the biggest x that would work is 4. Now, I want to convince you that this result should be entirely expected because of the following reason. So this is like absolute value of a thing. And remember that what is the characteristic shape of absolute value? A V, right? So somewhere in the problem, somehow, there's like a V floating around. It's more or less like this. And if you were to plot y equal to 11, what would it look like? It'd be a horizontal line, and in particular, it would be above the origin, right? Okay, so now, here's what I want you to see. So I'm going to change variables to a slightly different variable. So if I say that this is y is 11, and I say that this one is y is the absolute value of w. So I'm writing w because on this axis, this x is not here because we're playing with x. First we multiply by 4, then add 5, so this isn't x. But now what I want you to see is that reading this and interpreting that, if the inequality looks like this, and if we split it like this, then here's the deal. When we did this before, a couple pages ago, when it was equation, it was that we wanted this one to touch that one. Right? We wanted to know, where does red touch green? But now it says less or equal. So what preposition would fit for this? So instead of red touching green, instead of touching, I'll say that this is asking for, where is red below or touching green? So where is red below or touching? Well, is there anywhere where red is below or touching green? So how about right there for that point? So for that point, red is above green. So we're not talking about that point. What about that point? Is red below green there? It is, right? And all in here, red is below green. So what I want you to observe is that the place where it changes is right there. And everywhere where red is below green is all of this. So the solution to this exercise should be an interval of points. So that's the answer. So finally, I want you to consider the possibilities. So I'm not going to fill out this table. I want you to fill it out yourself. So what if we consider the absolute value of x is less or equal -4, the absolute value of x is greater than or equal to -4, like that, and the absolute value of x is less or equal to +4, and the absolute value of x is greater or equal to +4. So what I want you to do in all four cases is draw a picture okay, and then I want you to color in the points that will satisfy it. So you'll have a picture just like this, a V and a line, and some blue points. Good. So now let's have a quiz.